Welcome to another video of Edifo. In this video, I am going to demonstrate how we can conduct a one-sample t-test using SPSS and how we can explain the result of the test using API format. One-sample t-test is one of the very commonly used parametric tests. The one-sample t-test is used to compare the mean score of a sample with a known value, and it is usually the population mean. That is, one-sample t-test determines whether a sample comes from a population with a specific mean. Here, the sample mean is the observed average and the population mean is the expected average. Here we are comparing the observed mean, that is a sample mean, with the population mean, or we can say our expected mean. Using one sample t-test, we are going to compare means, that is compare sample mean with the population mean. A one sample t-test allows us to test whether a sample mean is of a normally distributed data significantly differs from a hypothesized value, that is the population mean. Here, population mean is considered as hypothesized mean. So, we can say sample mean compare with the hypothesized mean. The population mean is not always known but is sometimes hypothesized. That's why we can say population mean is a hypothesized mean. This test is especially used to test whether our sample comes from a particular population. Now, we need to understand what are the assumptions of one sample t-test. Because before using a one sample t-test, you need to make sure that your data is fit for conducting a one sample t-test. For a valid result, it needs to check whether your data fulfill the assumptions of one sample t-test. Here, we are going to discuss the assumptions about the one sample t-test. The first assumption is that the variable should be in the continuous form, or we can say in a quantitative form, that is the interval or ratio data. So the data should be collected in a quantitative form, not in a qualitative form. The categorical and ranked data are considered as qualitative data, but you need to collect the data for t-test that should be in interval or ratio data. Nominal or ordinal data cannot be used for conducting a one sample t-test. So it is crucial that if you collect data using a questionnaire, so draft questions for collecting data in interval or ratio type. The next assumption is that the data are independent. This is very important assumption for almost all parametric tests, which means that there is no relationship between the observations. Data point values for variables for different groups should be independent of each other. The next assumption is no significant outliers. What is an outlier? An outlier is an observation that lies an abnormal distance from other values in a random sample from a population. They are values that are notably different from other points. Here you just check the data 45, 46, 43, 44, 48, 47, 42, 40, 45, 90, 98. These are some data that I have collected. Suppose age of some people. Here the last two data you just watch it, 90 and 98, which is far different from other data. So we can say these two data, 90 and 98, are considered as outliers. They are significant outliers. If you are considering 90 and 98 for calculation of mean using this dataset, that mean should not be valid enough. So, outliers are problematic for many statistical analysis because they can cause tests to either miss significant findings or distort real results. So, if you are collecting data, first of all make sure that your data set shouldn't contain outliers. If outliers are there, remove the outliers, then take that data for analysis. The next assumption is assumption of normality. Almost all non-parametric tests follow this assumption of normality. The normality means that the distribution of the data is normally distributed. Here you can see two graphs. The first graph shows a normal distribution and second graph shows a skewed distribution. Here you can see a bell-shaped curve. A normal distribution depicts a bell-shaped curve. But a skewed distribution is not fit in a bell-shaped curve. You can see here a skewed distribution. So you should make sure that your data roughly fit a bell-shaped curve before running parametric statistical tests. If the data is not normally distributed, that is, the data is skewed. Here in the second graph, you can see a skewed distribution. You can select a non-parametric test. The core element of the assumptions of normality asserts that the distribution of sample mean is normal. In technical terms, the assumption of normality claims that the sampling distribution of the mean is normal. Here, your data is like the first figure, that is the normally distributed figure. You can opt the parametric, here the t-test. But your data is like the second figure, that is your data is skewed distribution. You cannot apply a parametric test like t-test. The next assumption is randomness. It's a common assumption for almost all parametric tests. Data for the test should be collected randomly. So these are the 5 important assumptions of t-test. The variable should be in continuous form, or we can say quantitative form. So you should collect the data in interval or ratio data. The second assumption, the data are independent of each other. The third one, no significant outliers, because outliers make your result insignificant. So avoid outliers. The next assumption is assumption of normality. Your data should be fit in a bell-shaped curve, not in a skewed curve. If it is not bell-shaped curve, you cannot apply t-test. Select some other equivalent non-parametric tests. The last assumption is randomness. That is, you should collect data randomly. So you need to check whether your data met all these assumptions. Then you can proceed with a t-test. Now we are going to our research problem. This is our research problem or research question. A company wants to improve the sales of their product. For that purpose, they plan to conduct an online advertising campaign for the promotion of the product. They assess the average sales per day for the product before the advertisement campaign was $5,230. They collected a sample of 150 days of sales figure after the implementation of the advertising campaign. We need to check whether any significant difference in means between sales figure before the advertisement campaign and after the advertising campaign. So here we are collected a sample of 150 days sales figure, and we have a hypothesized mean, or we can say the population mean, that is $5,230. So the procedure is we are going to compare these two means, that is 150 days sales figure mean and the hypothesized population mean, that is $5230, to check whether any significant difference between these two means. If there is a significant difference, we can conclude the influence of the advertisement campaign. If there is no difference, again we can conclude the influence of advertising campaign. So this is our research question. Now we move to SPSS for solving this problem. So open SPSS. This is the data set that I am going to test the t-test. So two variables. The first column, day, is a numerical type. Width is 8. There is no decimal place. The label name, days. And column 8, right aligned. This should be scale data. In SPSS, interval and ratio is termed as scale. Your data should be in scale data. Second data is our test variable, that is daily sales figure. So the name is sales and label name daily sales, and also it should be in scale data. Width is 8 and provided 2 decimal space. So shifting to data view, here I have already entered the sales figures of 150 days. You can download this data file from the description section below. I have already given a link. You can download this data file and you can use it for your practice. So to column days and sales figure. Now we are going to test whether this sample data, this is sample data, and we have already with a hypothesized mean, or we can say population mean. They have already collected before implementing the advertising campaign. They have already with a mean of population. Now we are going to calculate the mean of sample and going to compare the mean of sample with the hypothesized mean, or we can say the population mean. Okay, so for starting the one sample t-test, we just go to analyze menu and go to compare mean, because we are going to compare two means. So compare mean and select one sample t-test. So analyze, compare mean and one sample t-test. Click here. For more SPSS tutorials, I have already a playlist link given in the description section below. Go through that. You can learn the basic operations of SPSS. Okay. So here, this is a one sample t-test window. You can see the two variables in our data set. First one is day and second one is sales. Our test variable is sales. We need to calculate the mean of sales, that is sample data. So you should add the two test variable here. You can see test variable is empty. Select the test variable and click this arrow. Then we can add it to test variable. Okay. Now we are going to set the level of confidence. So for that, click the option confidence interval percentage 95. Normally 95 is considered as the default confidence interval percentage in almost all social research process. So leave as it is 95%. Then click continue. The next, we need to provide the population mean or hypothesized mean here, because we are going to compare this value with our sample mean. So we need to provide the hypothesized mean here. Our hypothesized mean is $5230. So you need to provide the hypothesized or population mean here. Okay, that's it. So first of all, you need to add the variable to test variable section. Then options, set the confidence interval percentage. Click on continue. The next is provide the population mean or hypothesized mean in the test value column. Then click OK. So this is the output window of SPSS. Here we have two tables. The first table is the descriptive statistical table and second table is the inferential statistical table. So check the first table. You can see the first column, the item daily sales, the number of days, that is n, it is a sample size, that is 150, and this is the sample mean. There's a mean of our sample, that is 5898.0533. This is a sample mean, and we have already a population mean or hypothesized mean. So this is a standard deviation, that is the deviation from mean. 59.39378 is the standard deviation, and this is the standard error of mean, that is very low. Normally it should be less than the standard deviation. So these are the different descriptive statistical figures: number of sample, mean of sample, standard deviation of sample, and standard error of mean. Now we move to the inferential statistical table. Here you can see the test value, that we are going to test this value with our sample mean. So $5230 that we have already given in the time of test, that is the population mean. Here the first column, that is the t value. This is the t value, 137.758. So this is a degree of freedom. Degree of freedom means n minus 1. That is the degree of freedom. Here only one sample, so we deduct the value from the n, that is the sample size. So 150 minus 1, that is 149, is the degree of freedom. The third column is the significant, two-tail, that is non-directional. So significance means here the p-value. The p-value in SPSS specifies as significance. So it is 0.000. So this is a mean difference. This is very important. Mean difference. You can identify the magnitude of difference using this column. The mean difference is the difference between the sample mean and the population mean. Here you can see the population mean. Population mean. Okay, population mean is 5230 and sample mean is 5898.0533. So the difference is 668.05333. This is a mean difference. Now this is a confidence interval at 95% level of significance. So 658.47072 to 677.6360. So this is a confidence interval, lower and upper interval. So this is a explanation of descriptive table and inferential table. Now we are going to check whether the difference is significant or not. That is, the difference between sample mean and hypothesized mean or population mean is significant or not. For that, you can follow three methods. For testing the difference of means, whether it is significant or not, you can follow three methods. The first method is the t-table critical value method. For this, we are going to compare the t critical value with the t value. For this purpose, you need to open the t table. It is available in the website. I have already given the link of this t table in the description section below. You can download it. Just open the t table. This is a t table. Here you can see in the left side the degree of freedom, and the top you can see the level of significance or alpha value. Here we are going to take the value of degree of freedom with 149. Our degree of freedom is 149. In this table, you can only see the degree of freedom 100 then 1000. So you just take 100. So the left side degree of freedom is 100. Then the top 0.05. The coinciding point, this is the t critical value we are extracted from t table. So the t critical value is 1.984. Clear? So t value is 137.758 and t critical value is 1.984. Now we are comparing these two values on the basis of some rule. Now the t value and t critical value. If the t value is greater than the t critical value, the means are different, significantly different. Here you can see the t critical value 1.984 and the t value is 137.758. Here the t value is far greater than the t critical value. So we can conclude that there is a significant difference in two means, that is sample mean and population mean. This is the first method. Now the second method. This is a very popular method and most of the researchers are following this method. That is the p-value approach. If the significant value, that's a p-value, is less than 0.05. 0.05 is 1 minus confidence level. That is 1 minus 0.95. 0.05. So it's a commonly applied alpha value. So if the p-value is less than 0.05, there is a significant difference between the sample mean and population mean. Get it? Here our significant value is 0.000, so that is less than our alpha value, that is 0.05. So we can say there is a difference between the test value, that is the population mean, and the sample mean. This is second method, p-value method. The third approach is the confidence interval approach. Here you can see the 95% confidence interval, lower figure and upper figure. The rule is that if in between these two values, if zero reside, that means there is no difference. That means this number reaching this number, if it crosses 0, then there is no difference. Here that not happen, because in between 658 and 677 there is no 0 value. Get it? If you want to see 0 in between two numbers, that two numbers should be the first one negative and second one positive. Here two numbers are positive, so you can't see a 0 in between these two numbers. Get it? If it is not, that means there is a significant difference between two means. Get it? So lower and upper, in between these two numbers, if you can see a 0, or we can say this number crosses 0, then there is no difference. Here that not the case, because both numbers are positive, so you can't see a 0 in between these two numbers. That means there is a significant difference in between two means. So these three methods you can apply to check whether the means are different or not, or means are significantly different or not. Here the first one, the t value is far greater than the t critical value of 1.9847. So there is a difference. Second method, the p value or significant value, which is less than 0.05. Again, there is a difference. The third one, in between these two values, there is no 0, so there is a significant difference. You can apply any one of this method. Here, the three methods are true in our case. A commonly applicable method is the p-value approach. Now, we are going to write the interpretation in APA format. So, for reporting in APA format, you need to first of all draw the table, both the descriptive and inferential table that we have already seen in the output window of SPSS. So just copy that table to a report, and this is the format of APA reporting. Sales figure was statistically significantly higher. Within bracket, M, that is a mean, 5898, standard deviation 59.4 than the population normal sales figure. T, within bracket degree of freedom, equal to, that is the t value, 137.758, comma, P equal to 0.000. So sales figures are statistically significantly higher. How we can get it? Because this mean is higher than this mean. So we can say statistically significantly higher. Within bracket, this is a M mean value, that is the mean value of sample, and standard deviation 59.4. The population normal scale figure, that is a normal, that is a population hypothesized mean. The t value is the t value here, then of degree of freedom, then t value p equal to. This way you can write in your research papers in APA format. This is the accepted APA format of one sample t-test reporting. So this is all about one sample t-test using SPSS and reporting in APA style. I hope you enjoy this video. If you like, you please like this video and please subscribe and click that bell icon for further update. So see you on next video. Thank you.